With the paper. Question number 6. This is about trigonometry. It's about identity in the first part, and on the next page it's about integration. So trig ID and trig integration. Now, which kind of identity are they making us use? Sine 3x plus 2x, which is sine of 5x. That's addition formula. Sine 3x minus 2x, that is sine of x, and there is a plus sign in the middle. So the orange working, the blue working. Sine of 3x plus 2x is sine of 5x, that is sine 3x. Cosine 2x, positive sign, cosine 3x, sine 2x. Similarly, sine bracket 3x minus 2x, that is sine 3x, cosine 2x, negative sign, and then it is cosine of 3x, sine of 2x. Since there is a positive sign in the middle, add it up. Which terms will be added up? This will be added to this one, and this and this eventually would cancel out. So I'm left with sine 3x plus 2x is sine 5x plus sine x equals to two terms of sine 3x and cosine 2x. But since they are saying prove that half of this, half of the left hand side should equal half of the right hand side, therefore this is sine 3x cosine of 2x. In other words, let me emphasize it further. This thing is equal to this thing, or this thing equals to this thing. Why am I pointing this way? Because that is exactly what the integration part is asking for. So therefore, integral between the limits 0 and pi by 4 of sine 3x cosine 2x, I have to integrate it, but it's not possible in this particular format. So half is outside, 0 and pi by 4. And then this is sine of 5x plus sine of x. Let me double check it once more. So this is sine of 3x and sine of 5x plus sine of x multiplied by half. That is sine 3x cosine 2x. Sine 3x cosine 2x. That sounds perfect. Now be very, very careful with the negative sign and with the exact trig ratios and so on. So now first thing first, half remains as it is. Start integrating. That is negative 1/5 cosine of 5x. And this is negative cosine x. And that is what you get after integration. Lower limit is 0, upper limit is pi by 4. First thing is, take the minus common out and take LCM. So therefore, if I take the minus common out, this is minus, and then there is a half, and after taking LCM, this is cosine of 5x plus 5 times cosine of x, and don't forget division by 5. So therefore, this is minus 1 over 10 between the limits cosine 5x and 5 cosine x between the limits 0 and pi by 4. Now if you want to get rid of this minus sign, which you should, the two limits would flip. So therefore this is positive 1 over 10. This is cosine of 5x. This is 5 times cosine of x. Upper limit is 0, lower limit is pi by 4. Now let me write some important information on the sides. The important information is that when x is 0, cosine of 0 is 1. That's the first thing. Let me write the second piece of info. When x is 0, cosine of 5 times 0 still cosine of 0, which is 1. So these two things are the same. Third piece of info. When x is pi by 4, cosine of pi by 4 is 1 over root 2, and in the rationalized form it's root 2 over 2. When x is pi by 4, cosine of 5 pi by 4, that will be in the third quadrant, that would be negative root 2 over 2. So this 4 pieces of info, it's what is needed for us. So therefore 1 over 10. So 1 over 10 is over here. Cosine of 5x with a 0 is cosine of 0. And 5 times cosine of 0 is this thing, that's your upper limit, minus cosine of 5 pi by 4 plus 5 times cosine of pi by 4, bracket closed. This thing is 1, this thing is 1. Cosine of 5 pi by 4 is minus root 2 over 2. Cosine of pi by 4 is positive root 2 over 2. Now be very careful with your working. So this is 1 over 10. This is 1 plus 5 into 1, which is 6. Leave it separate. Minus, this is minus root 2 over 2. And this is plus 5 root 2 over 2. Simplify on the inside first. So this is 1 over 10. This is 6 minus 5 root 2 minus root 2. That's 4 root 2 over 2. And simplify a bit over here. So this is 2 ones are and this is 2 twos are. This thing is gone. Now when I open up the bracket, what happens? When I open up the bracket, this is 6 over 10 and this is minus 2 root 2 over 10. Now simplify. 2 threes are, 2 fives are, 2 ones are, 2 fives are. So now take 1/5 common out and this is 3 minus root 2, which is the exact answer which is written at the top. So that is what we have proven. This is question number 6. Let's move to question number 7. What does it say? Question number 7 looks like it's a question of differential equation. And what kind of integration is asked? Let's see. So first of all, do the variable separable. 1 over y square dy. There is only one term of y. That is equals to 4x over e to the power 2x dx. Simplify it further. Y raised to power of minus 2 dy. 4x e raised to power of minus 2x dx. Now draw the integration sign. Draw the integration sign. The condition that's given to us, that is y is 1 when x is 0. Solve the differential equation. No particular term is asked. Yes, it's asked. Obtaining an expression for y in terms of x. So that is a necessity in this particular question. This is y minus 2 plus 1. Minus 2 plus 1. That is, this thing is integration by parts. U is 4x. dv is e raised to power of minus 2x dx. du is 4 dx. v integration, that's minus 1 over 2 e raised to power of minus 2x. Follow the arrows. So therefore this is, first write it over here. First simplify, minus half 4x e raised to power of minus 2x. This minus will make it positive. 4 over 2 is 2. 2 e raised to power of minus 2x dx. Simplify it further. Minus 2x e raised to power of minus 2x. Division by minus 2, that would make it negative. 2 over 2 cancels off. E raised to power of minus 2x. So therefore I can, let me write it first as it is. Minus 2x e raised to power of minus 2x minus e raised to power of minus 2x plus a constant of integration c. Let me simplify it a bit further and then let me evaluate the constant. This is minus 1 over y. This is minus 2x e raised to power of 2x. This is minus 1 over e raised to power of 2x plus a constant of integration c. Get rid of the minus sign. So this is 1 over y. And this is 2x over e raised to power of 2x plus 1 over e raised to power of 2x, and minus c is written as another constant which is plus t. I have changed it. Now when y is 1 when x is 0. Y is 1, 1 over 1, x is 0, 2 into 0 divided by e raised to power of 0, 1 over e raised to power of 0 plus d. This thing is 1, that's written. 2 into 0, this becomes 0. 1 over 1, this is 1. this is D. So therefore 1 and 1 cancels off, therefore D comes out to be 0. Do double check that in this thing the value of this thing is coming out to be 0. So now what do you have? You have 1 over y, that is 2x plus 1 over e raised to power of 2x. Flip both the fractions. Y over 1 is e raised to power of 2x over 2x plus 1, and I think that's it. So that's how the equation is found. So this is question number 7. Let's move to a lot of extra spaces given. Let's move to question number 8. This is a special kind of a trig identity, and in this one we'll be using the double angle formula and basic identity and so on. Now remember, sine square plus cos square equals to 1. So if I say sine square plus cos square, the whole thing square, can I write this thing as 1 square, so which is simply 1? Yes, I can. Now show that let sine theta equals to s, let cos theta equals to c. So c square plus s square square. Show that by first expanding, this is equals to this. Let me first expand. C power 4, 2s square c square plus c plus s power 4. This is the first thing. And this thing, the one in the middle, that is 2 multiplied with sine cos the whole thing square. Now this is c4 remains as it is, s4 remains as it is, c4 remains as it is, 2 multiplied with half sine 2 theta, the whole thing square plus s4. c4 plus 2 multiplied with 1/4 sine square 2 theta plus s4. What is it equal to? This is equal to this thing, which is 1. This is equal to 1. This is equals to 1. 1 over here, 1 over here, 1 over here, because it's the same thing, whether you expand it like this or you expand it like this. So a similar question came long time ago in the past papers. So therefore this is c4 plus s4 equals to 1 minus half sine square 2 theta. This is 1. This is basically this one and this one and so on, like this. So now that is what you have proven. What does it say? Hence solve the equation. So this is a trig ID and equation. The previous question was trig ID and integration. Hence solve the equation. This thing equals to 5 over 9. But this thing equals to 1 minus half sine square 2 theta equals to 5 over 9. Therefore negative half sine square 2 theta, 5 over 9 minus 1, that is negative 4 over 9. This negative and this negative cancels. Therefore sine square theta equals to 8 over 9. Therefore sine 2 theta equals to a square root of 8 divided by 3. That is what you get with a plus and a minus sign. Now the question is all about that theta lies between 0 and 180. So now you have this thing that you have to carry out the square root, and when you carry out the square root you have to work it out. So let me double check. So therefore you have there was nothing in common. Let me just double check. This is 1 minus half sine square 2 theta. So 1 is taken to the other side. So therefore this is 5 over 9 minus 1. That is 4 over 9 with a negative sign. The minus minus cancel out. Sine square theta is equals to 8 over 9. And this thing comes out to be root 8 over 3. And then you work out the basic angle. And then you get the answers. And this is just like a P1 working. So I won't spend so much time over here. This is for 4 marks. Let's move on. Now it says, one more thing. Don't forget that this is about 2 theta. So there are 2 cycles. So 2 theta lies between 0 and 360 degrees, but it's non-inclusive. So let me write this thing as 0 to 360, and then you have to take care of the basic angle and things like that. Question number 9. Now, question number 9 is about implicit differentiation. The first part is implicit, the second part is an extension of implicit in which the tangent is parallel to y-axis. Now, first thing first, differentiate y e to x minus y square e raised to power of x is derivative of 2. So this is product rule. This is y into 2e to x. And this is e to x, derivative of y is 1 dy by dx. That is for this part, let me label it. This part is just this whole thing. And now this part is coming up. So there is a minus sign. And then you have y square e raised to power of x. The derivative is e raised to power of x. And then e raised to power of x, derivative of y is 2y dy by dx. Derivative of a constant is 0. So therefore this is the orange one. Grab all the terms with dy by dx in it. So e raised to power of 2x dy by dx. And there is a minus sign. When you open it up, that is minus 2 y e raised to power of x. There is an ex and there is an e to x. So be very, very careful. Dy by dx. That is equals to y square ex. And this is 2y e to x minus 2y e to x. So now e to x, ex actually, no, sorry, dy by dx common out on the left hand side. And this is e to x minus 2y ex. And this is y square ex minus 2y e to x. So therefore dy by dx is, what should we take common out? We should take y common out. We should take ex common out. And what is left at the top? Only y. Okay, and what is left over here? That is 2ex. What's happening at the bottom? Take ex common out. And what are you left with? E raised to power of x minus 2y. Something like this. So now this ex and this ex cancels off. And you are left with a y at the top. Y minus 2ex at the top. And this is ex minus 2y. Let me double check. So 2y ex minus y squared. 2y ex minus y squared. The signs are flipped and the denominator is 2y minus ex. It's ex minus 2y. So you can also write this thing as 2exy minus y squared and flip the signs of the bottom. This is 2y minus ex. So that is exactly what is given. 2y ex minus y squared. 2y ex minus y squared. 2y minus ex. That's perfect. Now it says tangent is parallel to x-axis. That means y-axis. dy by dx is undefined. Numerator over denominator is undefined. What makes a denominator undefined? A denominator equals to 0. What is the denominator? Ex minus 2y minus ex equals to 0. So 2y minus ex equals to 0. 2y is equals to ex. Y is equals to half ex. So any which way, let's see how we should proceed. Now solve it with the original equation y e to x minus y square ex. Y e to x minus y square ex equals to 2. Y e to x y square ex equals to 2. Now what should I substitute? So either I can substitute ex, because what are they asking for? Exact coordinates of the curve. They're asking for the x coordinates. So it's your choice. What do you want to substitute? Let me substitute y. So this is half ex multiplied with e raised to power of 2x minus y square, which is half ex, another half ex, and multiplied by ex is equals to 2. So therefore this is ex, e to x, that is e raised to power of 3x. This is ex, ex, that is also e raised to power of 3x. What is left? You are left with a half minus you are left with 1/4, and this is equaling to. So half minus 1/4, when you take common, what do you get? E raised to power of 3x. Half minus 1/4 is 1/4 equals to 2. E raised to power of 3x equals to 8. That looks like a smooth answer. Ln e raised to power of 3x is ln of 8. 3x ln of e is ln of 8. X is 1/3 ln of 8. That is 1/3 ln of cube root of 8, which comes out to be, because 1/3 goes over there, so remove it from here. So therefore this comes out to be ln of 2. So x is equals to ln of 2. They're asking for the coordinates. So therefore y is equals to half ex. Y equals to half ex. That is half e raised to power of ln 2. And we know this rule that has come after a long time. That is that e raised to power of ln x equals to x provided x is greater than 0. So therefore e raised to power of ln 2, e raised to power of ln 2 is 2, half into 2 is 1. So therefore the coordinate is ln 2 comma 1. That is the coordinate of this particular point. So that completes this particular question. So question number 9 is done. They're asking for the coordinates, so write in the proper format. Question number 10. Now this thing is about vectors. It says, with respect to the origin, the position vector of the points A and B are given by such and such. Find the vector equation of a line. OA is 1, 2, minus 1. OB is 0, 3, and 1. And let me find AB or BA, doesn't make a difference. AB is OB minus OA. So this is 0, 3, 1, minus 1, 2, minus 1. 0 minus 1 is negative 1, 3 minus 2 is 1, 1 minus minus 1 is 2. So therefore the vector equation R is equals to something plus lambda something. So minus 1, 1, 2, that looks perfect. And I'll choose OB, which is 0, 3, and 1. So that's my equation. The point C lies on L and is such that AC is 3AB. Find the position vector of C. So what is AC? AC is 3 times AB. That's the first thing. And what else are they asking for? AC is OC minus OA. So this looks like basic O-level math stuff. And AB, coincidentally, I just found it, which is minus 1, 1, and 2. So this is minus 1, 1, and 2. Let me multiply minus 3, 3, and 6. This is OC minus OA. What is OA? OA is 1, 2, minus 1. It's 1, 2, and minus 1. Therefore, OC is minus 3, 3, and 6 plus 1, 2, minus 1. Minus 3 plus 1 is negative 2. 3 plus 2 is 5. 6 minus 1 is 5. So the answer is minus 2, 5, and 5. That makes perfect sense. They're asking for the position vector. That's perfect. If they would have asked for coordinates of C, I would write it minus 2, 5, comma 5. If. So now, what is it asking? It says find the possible position vectors of the point P such that OP is root 14. That means the magnitude. P is on L. Therefore, OP, the general term, can be written as OP as, where is this equation? 0 minus lambda, 3 plus lambda, 1 plus 2 lambda. 0 minus lambda, 3 plus lambda. 0 minus lambda, 3 plus lambda, 1 plus 2 lambda. So this is what you get. And then magnitude of OP is root 14. So therefore minus lambda whole square and 3 plus lambda whole square, 1 plus 2 lambda whole square is equals to root 14 whole square. So what you get is a quadratic expression. Let me proceed. This is lambda square. This is 9 plus 6 lambda plus lambda square. This is 1 plus 4 lambda plus 4 lambda square is equals to 14. So lambda square, 4 lambda square, that is 6 lambda square. And there is 6 lambda and there is 4 lambda, that is 10 lambda. and this is 9 and this is 1, that's 10. 10 minus 14 is negative 4 equals to 0. I can divide by 2. 3 lambda square plus 5 lambda minus 2 equals to 0. So 3 lambda square, and this is a plus b. Let me just double check one thing. 0 minus lambda, 3 plus lambda, 1 plus 2 lambda. 0 minus lambda, 3 plus lambda, 1 plus 2 lambda. So let me double check that this 3 becomes 9. 3 plus 3 is 6 lambda. Lambda square is lambda square. 1 is 1. 2 lambda is 4 lambda, and this is 4 lambda square. That's also perfect. Root 14 is 14. So this is 9, this is 110. 10 minus 14 is negative 4. That makes sense. And this thing is lambda square, and then a lambda square. This is also lambda square, a plus b whole square, and this is 4 lambda square. So this is 6 lambda square, and then you have 9, this 6 and this 4, that adds up to 10 lambda. So you get this equation. You would solve and you will find values of lambda. Lambda is something else, and what are they asking for? Find the possible position vectors of this thing. So this is OP minus lambda, 3 plus lambda, 1 plus 2 lambda. OP is minus lambda, 3 plus lambda, 1 plus 2 lambda. So one answer will be here and one answer would be here. Let's look at question number 11. That looks like the last question. What is question number 11 all about? It says the equation of a curve is such and such, find dy by dx. So this is differentiation, and dy by dx is there, and iteration. So it's a combination of all three. So now this is differentiation. Y is equals to tangent x raised to power of half. Dy by dx, half comes down. Tangent x remains as it is. Power reduces by 1. Derivative of bracket is sec square x. So therefore this is half, and the numerator is sec square x divided by square root of tangent x. But it's saying dy by dx should be in terms of tangent x. That means, do I have any identity that relates sec square? Yes. 1 plus tan square x is sec square x. So therefore, what I'll do is that I'll write half bracket 1 plus tan square x divided by square root of tangent x. So that is the working that you get for this particular part. So half is on the outside, 1 plus tan square and square root of tangent x. You can even write it like this: 1 plus tan square x divided by 2 square root of tangent x. They both are the same format. Or, now it says verify when x is pi by 4. We know that tangent of pi by 4 is 1. So therefore dy by dx is equals to 1 plus 1 square, because tangent of pi by 4 is 1. So this is 1 plus 1 square, and this is 2 times root of 1. This is 2 divided by 2. That comes out to be 1. That is one thing that we obtain. Now it says the value of dy by dx is also 1 at another point on the curve where x is equals to a, as shown in the diagram. What it means is that if there is a tangent over here, this gradient is 1. If there is a tangent at the point A, this line, these two lines are parallel. Now it does not look that much parallel because it's just a rough diagram, but let me get the hang of it. So something like this. These two lines are parallel. That means dy by dx is also 1 at this point. So show that you have a cubic equation like this. Now first thing first, let me look at the space. A lot of space is given. First thing is, we have dy by dx is 1 plus tan square x over 2 square root tangent x. Let it equal it to 1. So 1 plus tan square x, 1 plus t square divided by 2 root t equals to 1. where t is tangent a. Why? Because at a, dy by dx is equals to 1 plus tan square a over square root of tangent a, and there is a 2 over here. So now they have made the substitution where t is equals to tangent a. 1 plus t square is equals to 2 root t. Square both sides. When I square both sides, what do I get? So I get this thing, which is 1 plus t square, that is 2 root t, the whole thing square. You get 1, and this is 2t square plus t4. This is 4 multiplied with t. Therefore, t4 plus 2t square minus 4t plus 1 equals to 0. So this is a power 4 quartic equation. The thing that we have to prove, that is a equation, that's a cubic equation. Now, how come a quartic suddenly became a cubic? So that is something that requires a lot of expertise. That is, that we know this concept, that in a straight line, tangent of theta equals to gradient of the line. When theta is pi by 4, tangent of pi by 4 equals to 1. Got the idea? So the gradient is 1. That was already known over here. But can I also write this thing this way, that one of the value of tangent A should be 1? So this is also possible. So therefore, can I write it like this, that let tangent A equals to t. So t equals to 1. That means t minus 1 is a linear factor. That is the thing that was missing. So therefore, now when I do long division, so let me just draw a line in the middle. And now when I do long division, let's see how it goes. So let me just write this thing like this and like this. So therefore we have, let me shift this thing at the corner, so something like this. And over here, let me shift it a little bit over here. So we have t minus 1, that's a linear factor. And the quartic equation is t power 4. Let me write everything in small, t power 4. There is no t cube term, that is 0 t cube. And then there is 2t square and minus 4t plus 1. So now let's divide. First of all, take the highest power, divide, that is t cube. So this is t power 4 minus t cube. That's the first step. Change the sign and add. So this cancels off. This comes out to be t cube. Pull one more term down. That is 2t square. Repeat the process, t cube over t, that is t square. So therefore this is t cube minus t square. And now repeat the process. Change the sign and add. So 2t square plus t square, that is t cube. Pull one more term down. Repeat the process. Let me choose a different color, this time's blue. So t cube over t, that is t. So now this is not t cube, this is t square. So this is t square. Let me write it. So this is t square. Let me use blue like this. So therefore this is 2 plus 1. This is 3t square. So 3t square over t, that is 3. This is 3t square minus 3t. So this is t, so this is t, and this is 3t. Now change the sign and add. There is a minus sign, there is a plus sign. Minus 4t plus 3t, that is minus t plus 1. I've pulled the last term down. Minus t divided by t. So that is minus 1, that is minus t plus 1, and then change the sign and add. What do you get? You get a 0. That means the function is basically t minus 1 multiplied with t cube plus t square plus 3t minus 1. I think this is the working that they were asking for, where t is equals to tan A. This thing is equal to 0. Now based upon this, Now, all of a sudden, they have made use of an iterative formula.